We know that molecular compounds store energy in the covalent bonds between the atoms, and that the strength of these bonds depends on the identity of the atoms as well as the bond length. But ionic compounds also store energy in the electrostatic interactions they make between the ions in the solid lattice. These are ionic bonds, and ionic bonds can also vary in strength. The total energy stored between all the ions in the solid is called the lattice energy of the solid. This is the energy that would be required to separate all of the ions in the lattice until they were far away from one another and not interacting. This can be expressed as the following change in enthalpy, which is associated with pulling all the ions away from one another. The strength of the interactions in the lattice depends on a few factors, as is shown by the following equation. Here, C is a constant, so that doesn't vary. But the Z components represent the magnitude of the charges on the cation and anion. So the greater the magnitude of the charge on the ions, the stronger the interactions will be, and therefore the greater the lattice energy will be. So we can say that the lattice energy of an ionic solid is directly proportional to each of the formal charges involved. In addition, it is inversely proportional to the interionic distance, or the distance between the ions. That means that just like covalent bonds, larger ions won't be able to get as close to one another as smaller ions, so larger ions end up generating a lattice with less energy. Let's examine these two trends. Which of these compounds would have a greater lattice energy? Well, each of them has cations and anions of charge +1 and -1, so there will be no difference there. But sodium ions are smaller than potassium ions, and fluoride ions are smaller than chloride ions, so the interionic distance of sodium fluoride is quite a bit less, giving it a greater lattice energy. What about this pair? In this case, potassium and calcium are of nearly the same size, differing by only one proton. So the interionic distance won't make a huge impact. But whereas KCl has ions with charges of a magnitude of 1, CaO has ions with charges of +2 and -2. This affects the Z values from the equation, and the lattice energy will be roughly quadruple what we would expect for single charges. And now we know about bond strength for both covalent and ionic bonds.